Here are some problems from your Section 8.5 homework, starting on page 456. This whole lesson is about solving exponential and logarithmic equations. This particular problem, number 6, is an exponential equation. We talked about this in the lesson when we're trying to solve for the variable which happens to be the exponent. This particular problem, we need to isolate 3 to the x power first, and then I will show you what needs to be done. But if the number raised to the x is not isolated, that needs to be a first step. So here is subtracting 5 from both sides. Negative 3 to the x power is negative 45. And then we want this to be a positive base. That's easy enough to do. Just think about dividing both sides by negative 1. And that gives us 3 to the x power equals 45. Okay? And in the lesson, I made a strong emphasis on taking exponential equations like this, and they need to be rewritten in their log form. So exponential equations need to be written as log equations. And as a log equation, this would be log base 3, because 3 is the base of the exponent, of 45 equals the exponent that we're trying to find. Remember, logarithms are very simply, in the simple definition, they are exponents. So whenever you write the log equation, always let the log equal whatever the exponent is. Okay? And the way we're going to come up with this answer is by using that change of base formula. So you're definitely going to need your calculator. And with your calculator, I want you to find that button that has the word log on it. Okay? And I've hit the log button, and then immediately I get a left parenthesis on my calculator. So I'm going to input this top number, 45, and then I'm going to close the parentheses. Okay? So you've done log, you've put in the number 45, you close the parentheses, and now do divided by, hit your division symbol, hit the log button again, and this time you're going to put in the base number. So again, this little formula is called the change of base formula. It's easy to remember because the base always goes on the bottom. Okay, so these numbers, when you make this little fraction using log in both the numerator and the denominator, you just keep the numbers, top number on top, bottom number on bottom. All right, and so let's see what comes out. And on these problems, we're rounding to the nearest 10,000. That's 4 decimal places. So that's going to be 3. My calculator says 4649. So rounding up, that would be 4650. And since we rounded, we probably should go ahead and say approximately. So that's our value for x. X is approximately 3.4650. That's our answer for number 6. Okay, here's another one much like it. This is number 10 on your homework. The number raised to the power is already isolated. So I'm ready to go ahead and write this in log equation form. So that will be log base 25 of 144 equals the exponent 2x plus 1. Okay, now let's do our change of base formula again. So hit the log button, and on the top part of this fraction, you're going to put 144, close parentheses. Division, hit the divided by, and then hit the log button again, and this time you're going to put the number 25 in parentheses. All right, and hit your equals or enter key, and this says 1.54 and then it says 395, 1.5440. Okay. Now, what we've done so far is we've got the decimal form of this left side, and this is a little different because in order to solve this for x, we should know what to do here. We're still going to need to subtract 1 from both sides. Okay, so we'll show what that looks like, 0.5440, and now we still need to divide by 2 on both sides. All right, so just grab your calculator, 0.5440 divided by 2, and that's 0.2720. So my answer here, approximately, again, since we rounded, 0.2720. And once again, I'm going to go back, and you may have, this is probably a better idea if you do log of the top, log 144 divided by log 25. At this point, it's fine with me if you just leave that number in your calculator, that long decimal, go ahead and do -1 equals, and then divided by 2. And that is fine as far as basically what I want you to show is changing to log form, log equation form. Show me the change of base method. And then the rest of this, if you write it, that's fine. But you can pretty much just leave that long decimal in your calculator and do everything else, the other 2 steps, in your calculator. I'll leave that up to you, but I definitely want this and this to be shown as part of your work. Okay. All right. Let's try another one. This is very similar. This is number 24. It's a it's an exponential equation. Sorry. The base and the power is isolated. I don't have anything being added or subtracted to this number raised to the power, so I'm ready to write this in log equation form. So it's going to be log base 5 of 24 equals the exponent x plus 1. All right, so once again, you're going to use the change of base method. So hit your log button, put in 24, close parentheses, divided by, log again, put in the number 5, close parentheses, and just so you can tell if you did it right, your calculator should be showing, after you hit the equals key, 1.974635869. Okay, now at this point, we've already, I want you to drill this little change of base formula. So let's show this. And you can go ahead and round this if you like. I typically just like to leave that in my calculator and then do the other steps that are necessary in my calculator, but so you can see it. So to solve for x, obviously, I'm going to need to subtract 1 from both sides. So basically, I'm just going to subtract 1 from this long decimal. -1, and I get 0.9746. Okay, and that's your answer for number 24. All right, change of base method gives you a decimal, and then to solve for x, you just subtract 1. Okay. All right, now let's move on to a different type of equation. Obviously, these are log equations. Well, eventually, log equations need to be changed into exponential equations, like number 24. The problem is, before I can change these log equations into exponential equations, I'm going to have to apply some of those properties that we learned back in section 8.4. And I showed you one of these in your notes on the lesson. This is going to be an application of the power property, because before I can put this together as a exponential equation, I need to move any numbers that are being multiplied and make them become exponents. Okay, so you need to clear out any number that could be showing in front of the log as a multiplier. Okay, so that's easy enough. With the power property, that number could be moved as an exponent. Now you're ready to write this as an exponential equation. So remember, if there is no base showing, it's 10 as a base. Since logarithms are exponents, the logarithm equation will always equal the exponent. So my exponent for 10 will be -1, and I'm going to let that equal x squared. Okay, well, hopefully you know that 10 to the -1 is really 1/10. All right, and now to get our answer, we need to do the square root of both sides. And since this is an even root, we've talked about this before, I need to include plus minus. So let's grab your calculator and we'll find out what the square root of 1/10 is. So I'm just going to put 1/10 in parentheses, 1 divided by 10. And it comes out as 0.3162 rounded to the 4th decimal place. Now, let's talk about this for a second. In a previous lesson, we said that it was not possible, or it was undefined, if we attempt to find this log of a negative number. I'll take you back to section 8.3, and I think you had this particular problem, something like this on your homework. And it literally says 5 to what power would equal -25, and your answer was undefined or not possible. Well, that's really, if you go back to the original equation, that's what we're being asked to do here if we let x be -0.3162. We're going to be attempting to find the log of a negative number, and that is not possible as long as the base is a positive number, and it is. So even though we started off with the typical plus minus because we did an even root on both sides, the only good answer here is the positive, because if we check it against the original problem, the negative answer does not make sense, doesn't work. So in cases like that, when you have two answers, you need to take a look at the original. I'm not saying that negative answers never work. What I am saying is when you do get two answers like this, you need to take a look and see if a negative answer makes sense. Okay, now I'm going to change the problem, and just bear with me for a second. What if my original problem said this? Okay, I know it doesn't, but just bear with me for a second. Well, now a negative answer would work, because after you square the negative number, it becomes positive, and I would not be doing the log of a negative number. So I just threw that out there so that you wouldn't think, well, anytime I end up with two answers, I never use the negative. Well, that's not always true. You need to look at the original problem, and you need to decide, will I end up evaluating the log of a negative number in my original problem? And if the answer is yes, you throw out the negative and only keep the positive as your answer. Okay, hope that made sense. All right, let's try number 40. Similar, before I can convert this into an exponential equation, I need to get this ready to convert, which means I need to take this 2 that's currently multiplying by the log, and I need to make it become the exponent. So once again, this is the power property. This is one of the reasons why we learned that property. Okay, now you're ready to change this log equation into an exponential equation. So once again, take a look at the base. There is no base showing, so it's understood to be 10. Logarithms are exponents, so the exponent for 10 will be 5. And then we're going to let 10 to the 5th equal this x plus 1 quantity squared. Okay, a couple of ways of going about this. Remember from chapter 7, if I want to solve this for x, I need to raise this whole side to the inverse of 2, which would be to the 1/2 power. And I need to do the same thing to the left side. Whatever I do to one side, I must do the other. So this is going to be on the left side 10 to the 5/2 power. And on the right side, I get just x plus 1. Okay. Well, let's see. We can do this in our calculator. And let me show you how you can do that using a rational exponent if you don't already know. If you'll take your calculator and key in 10, and then use that raised to symbol. Now, it's very important that you put the fraction 5 divided by 2 in parentheses. Okay? If you don't use parentheses there, it's going to really throw off your answer. So hit the raised to, left parentheses, 5 divided by 2, close parentheses, and you should get 316.227766. And I'll write that out for you so you can see it. And if you didn't get that, check your parentheses around your fraction. Okay. Well, now it should be pretty easy to solve for x. I just need to subtract 1. So I've still got that number in my calculator. I'm just going to do minus 1 equals, and that puts it at 315.2278. We're still rounding to that 4th decimal place. And that's your answer for number 40. Okay. 46, another good problem. Another thing to keep in mind before you can change these log equations into exponential equations, multiple logs have to be written as a single log. And that's another reason why we learned those properties back in section 8.4. And this is a great problem because all 3 of the properties are going to be needed to turn these multiple logs in this equation into a single log. All right, so the first thing I'm going to do, just like we did on the previous 2 problems, I'm going to move the 3. It's going to become the exponent. I think I'm just going to do this a step at a time so you can follow along. Okay, power property was applied first. All right, now just go left to right, and I would suggest you just take them 2 at a time. This is the quotient property because I've got 2 logs of the same base being subtracted. I can put those together as a single log using division. And I'm just going to bring down this other log. Okay, so I would strongly recommend you just, till you get used to this, you just put these in pairs going left to right. Now I've got these 2 logs of the same base being added. This is the product property. So I can put these together as a single log using multiplication. And when I multiply these numbers together, I get 2.4x cubed over 6 equals 9. Okay, now that I've got all of this condensed into a single log equation, I can write the exponential form. All right, so once again, I always identify the base first, and it's 10. The exponent will be 9, and we're going to let 10 to the 9th equal this fraction, 2.4x cubed over 6. Okay, now let's grab our calculator. And I'll just kind of step you through most of this from this point on. The calculator is going to do the work. All right, so let's just go ahead and raise 10 to the 9th power. Just do some little steps over here so you can follow. You got 10 to the 9th equals, okay. Now, leaving that number in your calculator, my next move to solve for x, I need to multiply by 6. That's going to clear out this denominator on the right side. They'll cancel. Okay, so just leave that number in your calculator and then do times 6 equals. All right, just let that number sit there in your calculator. And now we have this number. I'll just write it out for you. Huge number. Okay. Okay, now it should be pretty easy. I'm just going to leave that sitting in my calculator. I'm going to divide by 2.4. All right, that gets me to here. All right, and we're almost there. And now I need to do basically the cube root of both sides, or in other words, another way of doing the cube root is just to raise a number to the 1/3 power. So once again, just leave that big number sitting there in your calculator. All right. And here we are down at this part. With that number in your calculator, you're going to hit the raise to button. And again, it's very important. If you're going to let a fraction be an exponent, you need to put that fraction in parentheses. So left parentheses, 1 divided by 3. That's just another way of doing a cube root. Close parentheses equals. Okay, and hopefully you got 1357.2088. And that ends up being our approximate answer since we rounded to the 4th decimal place. And I hope you followed that. This is a great problem to utilize all the properties and to get it to single log, then exponential form, and then it's just basic algebra that you should understand. Trying to get x by itself, multiply by the denominator first, do the division, and then the cube root. Okay, so that should be your answer for number 46. So I would definitely make sure you can do this one on your own, because I believe there's a test problem very much like this one. So this would be a good one for you to practice. Okay, I think this is my last example. And once again, we're going to be forced to pull out a couple of our properties so that we can put these two different logs together as a single log. First move will be, before I can make these two become 1, I need to move this 2 and make it become the exponent for x. Okay, that's the power property. Now the product property. I'm going to put these two together as a single log using multiplication. All right, and now we're going to change it. Now that it's a single log, we're going to make it an exponential equation. The base is 10 raised to the 6th power equals 4x squared. All right, so once again, let's clear your calculator. Let's do 10 to the 6th power. Just leave it there. Okay, once again, if you're not sure about that, 10 to the 6th power equals. All right, you got that number there in your calculator. Should be divided now by 4. So just hit your division button. Divided by 4. Okay, I'll just show our steps like this. And you got 250,000 is x squared. And now we need to, another way of saying the square root of both sides is by raising to the 1/2 power. So once again, you've got 250,000 sitting there in your calculator. You're going to hit the raise to in parentheses 1 divided by 2 close parentheses. That's another way of doing the square root. Okay, but please don't forget parentheses if you have the calculator like mine. Now, some calculators they may provide them for you, but mine doesn't. So, and that gets us down to a good answer of 500. Okay, and that's all the examples I have. I tried to do some of a little bit, different, pretty representative of the whole assignment. But if you have any questions, feel free to contact me, and we'll go over these next time.